Let's begin section 9.3, similar right triangles. So as we begin here, we've got a term called geometric mean. We will get to that shortly. So let's go ahead and take a look at right triangle similarity theorem. And so it says if an altitude is drawn to the hypotenuse of a right triangle, then two triangles are formed to the original triangle and to each other. Here's how I look at this. In the diagram right here, I'll go ahead and circle that. There's a big triangle, and there's a triangle to the left and triangle to the right. And so what I tend to do on these problems is I'll go ahead and begin by drawing out three triangles. So I'll go ahead and do that right here. And hopefully, once again, you realize that we have not just three triangles, but they're similar in the fact that they have their right triangles. Okay, so I've got three right triangles. I'll call the first one the big triangle. The next one, I'll call it the triangle on the left. And then we have the triangle on the right. Because if you look at it, we have the big triangle. And I'll go ahead, let me highlight that in blue right here. So we've got big triangle. The triangle to the left, I'll go ahead and highlight in red. And then we have the triangle on the right. Small triangle. Right, big triangle, left triangle, right triangle. It doesn't really matter how you want to label it, but like I said, I tend to look at the triangle and break it down into three triangles. Now the sides right here are always consistent, okay? I'll go ahead, if you look, we'll have, this is the short side or short leg. Down here, we'll call these ones the long leg. And then obviously this right there will be your hypotenuse. Can't be anything else, right? Opposite of the 90-degree angle. So on all three triangles, I'm going to set it up where I have short leg, long leg, hypotenuse. And if you look at the triangle itself in the diagram, majority of the time, you'll be able to recognize which is the long leg, which is the short leg, and which one is the hypotenuse. The hypotenuse should be the most obvious one. Sometimes the long leg and short leg can be a little dicey. But I split it apart, and then I'm going to start labeling things, and I'll show you why later on when we solve these problems. All right, so in the triangle similarity, you can see that, hey, if I split these apart, you can see which triangles or what sides are similar to each other, and then make sure you write the similarity theorem accordingly. Let's go ahead and take a look at this geometric mean. The geometric mean of two positive numbers, a and b, is the positive number, x, that satisfies. And it's always going to look like this. We have ourselves a over x is equal to x over b. All right? And so if you want to solve for x, all you end up doing is you cross multiply. All right? So x times x, and that's where they got the x squared times ab. And then remember, to get rid of the exponent, we go ahead and square root both sides, and x is equal to rad ab. Okay, so that's how you can go ahead and start simplifying things. Sometimes they might ask you to leave it in simplest radical form rather than a decimal, and so you can go ahead and make sure you leave it in simplest radical form. All right, moving along. So sometimes depending on the parts of the triangle that's given to you and the numbers that they give you for the sides, what they're saying here is this. In a right triangle, the altitude of the right angle to the hypotenuse divides the hypotenuse into two segments. So the length of the altitude, okay, so the length of the altitude, I'll go ahead, that is C to D. Okay, that's the length of the altitude of the triangle. So if you take CD and you square it, They're saying that's equal to segment AD. I'll go ahead and sketch that or highlight that in green, times segment BD right here. So CD squared is equal to AD times BD, or wherever the altitude of the big triangle is, right? That'll you square it, it's equal to the two little sides, the green and the red one right there. And so you can use this on a problem where they give you the altitude and they give you either AD or BD or one of those two segments. They got to give you two out of the three in order for you to use this. It works. It's great. If not, you can go back and use the method I'm going to show you with the three triangles, splitting them apart. Next up, Theorem 9.8, the geometric leg or geometric mean leg theorem. This says in a right triangle, the altitude of the right angle to the hypotenuse divides the hypotenuse into two segments. So right here, if I highlight segment C to B and you square it, that's going to be equal to DB right here times A to B, which happens to be the whole entire thing. So things change up a little bit right here. All right, C to B is equal to the two segments that are now on part of the hypotenuse there. All right, so if we take a look at it again in the second one, I'll go ahead and erase that, the colored markings that I have there, and we take a look at A to C. Okay, so if we take AC and use that as the hypotenuse for the triangle right here, the other two sides right there would be A to D times A to B, once again that whole entire side, and there you go. All right, so I try to color coordinate things to kind of show you visually what parts they're talking about, and that will allow you to use the geometric mean leg theorem. So let's put all this together. Let's take a look at our extra practice. So we have our triangles. There should be three. We want to make sure we identify the three triangles. And we got big triangle, small triangle, triangle to the left, triangle to the, big triangle, triangle to the left, triangle to the right. So if I take a look at the big triangle, let's start with the right angle right there. And so I'll go ahead and start this off with triangle, let's say JHI. Okay. So that right there should be similar to, let's go ahead and talk about the triangle to the left. And I'll start with the right angle, and I'll put triangle K, and then we'll go ahead and put right there JH. And then so we have also the triangle to the right, where it's similar to, and we have ourselves triangle K, J, I. And so I went ahead and made sure that I labeled and wrote down the three similar triangles, and I tried to also put the sides down, or the corresponding angles and sides down together. Okay, so we have our triangle similarity statement. Let's go next up to number 3. Okay, so we want to find the geometric mean of the two numbers. So if you remember, we have ourselves a ratio or a proportion that we have. On one part we have A and B, the other sides we have X. So the 2 and the 3, I'm going to go ahead and put those in for A and B. And so x's will stay in their spot. So next up, let's go ahead, we'll cross multiply. And I've got x squared is equal to 12. Let's go ahead and solve things out. Remember, we want to put things, let's put things in simplest radical form. And so we'll square root both sides, and I got rad 12. Perfect square factors of 12, 4 and 3. Right? In case you weren't certain, I'm going to split it up with perfect square factors. 4 times 3, because I can take the square root of 4, and then we end up with 2 rad 3. And there you go, you have found the geometric mean. All right, key things right here. The two numbers 2 and 6, make sure you put them in the right spots where A and B is. All right, so I went ahead and highlighted that for you right there, so you know where those numbers go in the proportion. All right, so now let's take a look at number 5. So I tried showing you different ways of solving this. What I personally like to do, I think it never fails, and it's a lot easier because sometimes you forget about the different geometric means, leg and geometric mean altitude, is we start off with 3 triangles. And remember, in these 3 triangles, I've got big triangle, which is the whole, okay, the whole thing. So I'll go ahead and right here, I'll label this big, left, and right. So in the big triangle, and then remember we have ourselves the short leg over here, and then down below we have ourselves the long leg. And then the slant is your hypotenuse. So when you look at the diagram, we obviously have a right triangle. And so then at least you should know where the hypotenuse stands because it's opposite of the right angle. So for the big triangle, the information that they give me is the hypotenuse, which is going to be 16 plus 9. And that right there is 25. So let me go ahead and label that. All right, the triangle to the left, the x, does that look like the long side or the short? Long leg, short leg. To me, short leg, x. 16 right here ends up being the long leg, so I'll put that down right there in the section for the long leg. And then now let's take a look at the triangle to the right. I see 9, short leg, x, long leg. So what happens now is this. I take a look at the 3 triangles, and I want to see, all right, are there 2 triangles where there's information where they give us information about the length of the legs, and there are. It's these 2 right here. I see an x and 9 for the short leg. I see 16 and x for the long leg. So what I'm going to be able to do now is go ahead and come up with the proportion and write the proportion out so that I can solve for x. Similar to that of the geometric means altitude, right? So that's what this is all about right here, or sorry, the geometric mean altitude theorem. And I'm going to go ahead, you can see how it works out because I'm going to go ahead and put x over 9. That's equal to 16 over x. And then you can go ahead and cross multiply, solve things out, and you'll get yourself your answer. So cross multiply, x times x is x squared, 9 times 16, that ends up becoming 144. So if you forget the theorem, what I'm showing you right here is that this will pretty much work like 99% of the time, okay? And we compare the 3 triangles, we figure out which triangles have common sides, all right, or corresponding sides where there's information, and then we come up and start our proportion. And there you go. X ends up equaling 12 right here for number 5. All right. Let's go ahead. Let's repeat this with number 6. You may think it's pretty tedious at times, but once you have it down, it goes real easy. Okay, a big triangle first. I've got the hypotenuse, which is 11. I've got the long leg, which is y. Looking at the triangle to the left, I've got hypotenuse is y. 9 looks like the long leg. I'll put that right there. And then with the triangle to the right, I want to go ahead and put, all they give us is the short leg, which is 2. So remember, after that, I'm taking a look at the information and this is what I see. I have, with those 2 triangles, I've got corresponding parts where I could set up my proportion. So let's do it. So I'm going to go ahead. We got 11 over y, okay, and it's the one that's both hypotenuse equal to y over 9, which happens to be the long legs for both triangles. All right. So then, just like that, we've set this up. I've got y squared is equal to 99, right? Cross multiplying. And then let's go ahead. We'll simplify this out. Square root both sides. And y is equal to rad 99. But I can simplify this, thinking of factors of 99. Perfect square factors, 9 times 11. Because the square root of 9 is 3, I've got 3 rad 11. And there you have your answer for number 6. All right. Hopefully you're getting the hang of it. Let's go ahead and take a look next up at number 7 right here. Okay. So 3 triangles once again. Big triangle, triangle to the left, triangle to the right. Okay, so with the big triangle, I see short leg is 49. The long leg is t, or sorry, that's the hypotenuse right there. Looking at the triangle to the left, let's see, what do they give me? They don't really give me a whole lot. It looks like the short leg would be, we could say that that's t minus 7. That'll be the long leg. But really, they don't give us a whole lot here to work with. But then hopefully they give us enough on the triangle to the right. On the triangle to the right, I've got short leg is 7. That 49 right here looks to be the hypotenuse, right? Opposite of that right angle. And so I'm going to go ahead and use these 2 triangles right here to set up my proportion. And then so I'm going to go ahead and put 49 over 7 is equal to t over 49. And right here, we just go ahead. We don't have 2 variables, we just have 1. So let's cross multiply and let's solve things out. I've got 7t is equal to 49 times 49, which ends up being 2,400 and, let me double check right here. $49 times 49, 2,401. So after that, let's go ahead and divide both sides by 7, and t ends up equaling 343. Okay, and there you go. Just like that. All right, one last example right here. Let's go ahead and erase some of the stuff there. And okay, so let's take a look. I've got, once again, big triangle, triangle to the left, triangle to the right. All right, big triangle right here. I see the hypotenuse, and that's going to be a plus 4 plus 3. So a plus 7. On the triangle to the left side, I've got short leg is 3, long leg is 6. And then on the triangle to the right, I've got short leg is 6, long leg is a plus 4. So we'll go ahead and put things together right here. We've got 3 over 6 is equal to, okay, remember this is short leg and short leg of both triangles. On the second side, we got ourselves 6 over a plus 4. All right, so now let's go ahead. We'll cross multiply. Don't forget to distribute. That's going to be the key right here. And I've got 3a plus 12. That's equal to 36. All right, and then let's finish this off. I'll subtract 12 to both sides. 3a is equal to 24. Divide both sides by 3, and a is equal to 8. All right. Hey, you did it. Now you can go ahead and solve each of these triangles, no matter what size that they give you, by splitting up the triangles. Once again, big triangle, triangle to the left, triangle to the right. I always have the vertical side as the short leg, the horizontal side as the long leg. And then we have the hypotenuse opposite of the 90-degree angle. There's a geometric mean altitude and geometric mean leg theorem. You can use those if you feel familiar with it. However, you can't always use that for every problem. What you can do is split the problem or split the triangles up and then match and see, well, which two triangles have corresponding parts where I can set up my proportion. And that's what I try and showing you with the highlighted parts right here. And I went ahead and highlighted that triangle in number 8. All right, so there you go, 9.3, similar right triangles. Start setting up some proportions, start splitting up those triangles, okay, to help you solve these problems out. There you go.